Hello everyone, I'm Ning. Today I will introduce financial risk prediction with XAI. The data comes from the loan records of a credit platform and contains of 47 columns of information on variables such as loan amount, term, and purpose. We select 800,000 entries for training and 200,000 each for test set A and B. And we process data in three steps: data cleaning, label encoding, and split and smooth. First, we remove duplicates and missing values while checking for screeners and outliers. And we also convert category variables into numerical values using label encoding. Finally, we split the data set into training and testing set and apply smooth to balance the class distribution. After exploring the data, we find that interest rate and loan purpose have the highest importance, as interest rate affect repayment ability and loan purpose reflect financial probabilities and risk. In contrast, the lower bound of the FICO credit range and long term shows low importance. We use PyCharacter to find the best model, and different models perform best across different metrics. Overall, XGBoost and AdaBoost achieve better results, and PyCharacter select LDA as the best model, but its accuracy on the test dataset was unsatisfactory, and the training score and the cross-validation score were close and relatively low, indicating high bias and underfitting. And this suggests that LDA may be too simple for data. And we ultimately select XGBoost and used Grid Search CV to fine tune its hyperparameters. Initially, accuracy was 0.67, but after tuning key parameters like the confusion matrix shows fewer it improved to 0.935, and the confusion matrix shows fewer misclassifications, proving the effectiveness of optimization. And the partial dependence plot shows how interest rate and loan purpose impact predictions. Dependence on interest rate increases stability and until around 15%, then fluctuates slightly but remains high, suggesting that higher interest rate correlated with a higher likelihood of default. And loan purpose exists a sharp drop at zero, indicating the certain purpose significantly affect predictions. And the limb visualization explains a specific instance. The prediction probability for non-default is 99%, while default is 1%. And key features influencing this decision include interest rate, earliest credit line, total accounts, open account, and loan purpose. Lower interest rate and early credit line and a high total account strongly contribute to non-default predictions. And open accounts and loan purpose slightly increase like the likelihood of default but have minimal impact. The ice plot with PDP show feature impacts. Interest rate has a strong positive effect, especially between 10% and 15%, indicating the higher rates increase default risk. Earliest credit line remains stable, suggesting that older credit history risk but have a weaker effect. And total accounts show a downward trend, implying that more accounts reduce default probability. And open accounts fluctuate, indicating complex interactions, and the revolving balance has a slight upper effect, suggesting that a higher balance may increase risk, but not significantly. And the Andrew method provides a rule-based explanation where it has high precision. The coverage is very small, meaning the rule applies to a very small portion of the dataset. And the decision tree served as a surrogate model to approximate and interpret predictions. The rule notes split interest rate, indicating its crucial role in determining loan outcomes, and the loan purpose, revealing balance, and total accounts are also very key predictions. And the model performed well but has room for improvement. The confusion matrix show it correctly classifies most non-default cases but struggled with identifying defaults, with 27 false negatives. This suggests it's reliable for predicting low-risk borrowers, but may underestimate risk for some high-risk cases. The learning curve indicates potential overfitting as training score is nearly perfect, while the cross-validation score is low. However, a validation performance remains high. The ROC on course curve suggests moderate discrimination ability, and the precision record curve highlights challenges in handling balanced data. Finally, we can evaluate fairness by examining protected attributes and assessing disparities in prediction. Demographic parties can compare default predictions rates across groups, while uh, equalized all check for differences in false positives and false negatives. If significant bias is detected, adjustments such as revealing or alternative model strategies can improve fairness while maintaining performances. And that's all of our content. Thank you.